So in the phase 2, that is related to the physical metallurgy. Here we are supposed to know about the alloy system. When you take any material, it is not obtained in the pure form. It will be having different combinations of material, so which has to be separated based on the name. So material may be in the pure form or in the alloys with some impurities. Any material or any metal, you cannot get it in the required pure form. So the impurities has to be removed. So when you go with the alloy system, the phase changes happens. So you are supposed to know different terminology, what is solute, what is solvent, and what is solution. So by knowing this distinction, we will be able to tell how the phase, what phase it is. A solvent is an element or component that is present in the greatest amount. On occasion, solvent atoms are also called host atoms. So solvent is also known as host atom, and that is also present in great amount. If it is solute, it is used to denote an element or compound present in minor concentrations. So solvent is major or greatest amount, solute is which is present in minor concentration. So then what is a solution? Solution is formed in the solid state when as the solute atoms are added to the host material under the condition that the crystal structure is maintained and no new structures are formed is called a solid solution. So like this, when we go with phase transformation, you must be able to distinguish between solution, solute, and the solvent. So when we classify solid solutions, so there are two solid. One is the interstitial and substitutional. What is interstitial solid solution? So interstitial solid solutions have impurity atoms with the tetrahedral and octahedral structures. Voids or interstices are among the host atoms. So here interstitial impurity will be present. And the substitutional atom is if there is a high concentration compared to the existing atoms, so bigger size atom will go and come and occupy the position. So that is known as substitutional impurity atom. So carbon is an interstitial solute in FCC structure of iron, occupies octahedral voids in FCC structure. So if you apply Hume-Rothery rule, so there are 4 rules to be formed to substitutional solid solution. One is the atomic size factor, crystal structure, electronegativity factor, valence, it is there. So atomic size factor is appreciable quantities of a solute may be accommodated in this type of solution. If it is crystal structure, if you take the crystal structure for metals of both atom types must be same. Electronegativity factor, the more electropositive one element and more electronegative other element, greater the likelihood they will form an intermetallic compound instead of substitutional solid atoms. If it is valence, a metal has more of a tendency to dissolve another metal or higher valency than to dissolve one of a lower valency. Example of substitutional solid is found for copper and nickel. These elements are completely soluble in one another at all proportions. With regard to the aforementioned rules that govern the degree of solubility, the atomic radii of copper and nickel are 0.128 and 0.125. And the structure what they got is FCC structure. Their electronegativities are 1.9 and 1.8. So further, if we see what is phase diagram, phase diagrams are the map that give relation between phases in equilibrium in a system as a function of temperature, pressure, and composition. So what is a component? Component are pure metals or compounds of which an alloy is composed. What is a system? System has two meanings. System refers to a specific body of material under consideration. It may relate to the series of possible alloys consisting of the same components but without regard of alloy composition. What is a phase? Phase can be defined as a physically distinct and chemically homogeneous and mechanically separable region of a system that has a particular chemical composition and structure. Example is water in liquid or vapor state in a single phase. So what is Gibbs phase rule is P plus of F is equal to C plus of N. So where P is the number of phases, F is the number of degrees of freedom, C is the number of variables, C is the number of components in the system. So both must get compensated. So based on the values we can tell the phases in what, whether it's a single phase, two phase or three phase. If F is equal to 2 and P is equal to 1, that is in a single phase region. If F is equal to 1 and P is equal to 2, then it's a two phase region. If F is equal to 0 and P is equal to 3 means that is a three phase region. So P value indicates that the phase region. P is equal to 1 means single phase, P is equal to 2 means two phase, P is equal to 3 means three phase. So what is solubility limit? For any alloy system, there is a maximum concentration of solute atoms that may dissolve in the solvent to form a solid solution, that is known as solubility limit. Addition of solid in excess of the solubility limit results in formation of another solid solution or compound that has a distinctly different composition. What is phase equilibrium? Phase equilibrium is a state in which opposing forces or influences are balanced. What is metastable state? Metastable state is at a state of equilibrium never completely achieved, but rate of approach to equilibrium is extremely slow. A metastable state or microstructure may persist indefinitely, experiencing only extremely slight and almost imperceptible changes as time progresses.